Getting into section 4.3 today. So third section of chapter 4, we are now looking at congruent triangles. So this was really the major reason that we covered chapter 9 before chapter 4 is because I kept mentioning that idea of congruent triangles. And so what does it take for two triangles to be congruent? Right? And this is something I kept mentioning in our chapter 9 videos was in order for two triangles to be congruent, all 6 of their corresponding parts must be congruent. Right? So that's the key. So as I look at this guy right here, so this is a super important piece of information right here. This is called a congruence statement. So whenever we write a congruence statement stating that this triangle is congruent to this triangle, one of the main ideas that you're going to keep hearing me saying all chapter long is the important thing about a congruent statement is that order matters. Order matters. In other words, if I say that triangle ABC is congruent to triangle RST, so you got to look at the order that these letters are placed. So what this is telling me is that angle A is congruent to angle R, angle B is congruent to angle S, and angle C is congruent to angle T. So that's the first part, is it's telling me that these 3 angles correspond and are congruent to these 3 angles. So if you look at these 2 triangles, that's what's going on here. So you see the single mark here for A matches up with the single mark for R, and that's because those are the first 2 letters mentioned. The middle 2, B and S, so you'll notice that B has the double mark and S has the double mark. So I know those 2 angles are congruent to each other, and then of course you got the third angle for C and T. Those guys got the 3 arcs. So right, I'm seeing that which angles are congruent to other angles on the other triangle. So those are the angles. The sides are also matching up. So side AB goes with side RS. All right, so if I look at AB, it has the single mark. RS has the single mark for that side. So this side is congruent to this side. BC is congruent to ST. So here's BC, it has the triple mark. Here's ST, it has the triple mark. And then the last one, if I look at the bookends, so AC and RT go together. Right? So AC has the double mark, RT has the double mark. So the idea is when we have congruent triangles, all 6 parts are congruent. And within a congruent statement, we're being told which parts from this triangle correspond to this triangle. All right, so super, super important when we look at a congruent statement. One of the theorems that gets thrown in now at this point is something called the third angles theorem. The third angles theorem. And all it simply says is that if you have 2 triangles, if you know that 2 of the angles of one triangle are congruent to 2 angles of another triangle, right? So if I only know 2 angles from each, well, by default, automatically the third ones are going to have to be congruent too. Right? The third ones would also have to be congruent. There's no possible triangle you could draw where 2 of the angles match up from the 2 triangles, but then the third ones are different. Right? That's not possible. So that was our third angles theorem. Third angles theorem. So let's go through a couple examples. By the way, if you're writing down these own notes, you need to write this stuff down. Okay, so you need to write down the information that you see here. You need to write down the third angles theorem, and then you can start writing down these examples that we're going to go through as well. So make sure all of this, what I'm seeing on this page, makes it into your notes. So as I look at this example, so again, right here, guys, you have a congruent statement. Super important. Don't ever overlook the congruent statement, because when we look at the congruent statement, it tells you, again, which parts from this triangle correspond to which parts on this triangle. Right? So right here, they've identified all 6 corresponding congruent parts. Right? So they got the 3 angles that match. You got the 3 sides that match. Okay, and so that's what we're being told if these guys are congruent triangles. Okay, so we got to name the pairs. And again, guys, when you go on to name this information, like I said, sometimes it can be a little difficult to tell just by looking at the triangles, because they might be rotated differently, and it can be hard to tell visually which parts match. It's easy in cases like this, when the 2 triangles are drawn going the same direction. So it's very easy to tell which parts match, right? So in those diagrams, that's going to be easy to tell. obviously, and they're marked, right? So by the markings I could tell. But in other triangles, it can be easiest to just look at the congruence statement to figure out what parts go together. Okay, and so we're naming 3 angles and 3 sides that are congruent to each other. So let's look down at these. So if I have a congruent statement, like I said, just go off the statement to figure out what 6 parts go together. But if I don't have a congruent statement, like if I look at exercise number 1, and again, guys, as you're taking notes, you need to draw these figures. But as I look at those 3 diagrams, so here's the other scenario. This is the scenario where I am given the diagrams, and I am told which parts go together by the markings on the diagram, not by a congruent statement. Okay, so in this case, they want me to show that these 2 triangles are congruent by identifying all 6 corresponding parts. And then we'll write the congruent statement. Okay, so as I look at these, let's start naming the 6 parts. Let's start with the 3 angles. Obviously, angle A corresponds to angle J. So angle A is congruent to angle J. Let's go for the double marks, angle B and angle K. And then the triples, angle C and angle L. All right, so those are the 3 angles. Let's name the 3 sides. So if you look at that single mark right there, so side AB goes with JK. So AB is congruent to JK. The double marks BC with KL. And then the third ones, we got AC going with JL. There we go. So we just named all 6 corresponding parts. So now we can write a congruent statement, right? Just like the one we saw up above. So if you look at this triangle, I'm going to say triangle ABC is congruent to triangle, and here's where the order I got to make sure things match up. I can put this in any order I want, as long as these 3, the 3 that need to go with the 3 over here, are matched accordingly, right? So if I'm going to start with angle A here, well, because it's congruent to angle J, I got to start with the J here. And if I got B in the middle, because B is congruent to K, K needs to be in the middle also. And then the third one is C. He corresponds to angle L. So those guys go together. So again, guys, the big idea on a congruent statement is that order matters. Okay, order matters. Again, I can switch the order of these as long as I switch the order of these to match corresponding parts. Okay, so we're going to try this for one more. I'm going to jump over to number 3. I'm going to jump to number 3. Because on number 2, it's pretty much the same as this. Right? I can simply go off of the marks. I know that A goes with D. I know that B goes with C. Guys, one thing I would mention on this is, remember now when you have 2 triangles put together like this, you cannot use a single letter for certain angles. Like if I just said angle B, well, you wouldn't know if I'm talking about this little guy or the medium-sized one or the whole thing of angle B. There's literally 3 angles right there I could be referring to. So in a case like that, you do need to use 3 letters to name the angle. If I wanted to talk about that little guy right there, I would have to say something like angle ABC, right? Something like that. If I wanted to talk about this angle, I could name it angle CBD, something like that. So if there's more than one potential angle for that letter, you do have to use 3 letters to name it. In a case like this, where when I say angle A, there's only one angle I could be talking about, right? It's only possible for one angle here, so I can name this angle A. That's okay. Same with D, right? We could use 3 letters, and sometimes the book does. Like they'll still call this CAB to refer to this angle, even though it's not required, because there's only one potential angle for angle A. But I want to go to number 3 here because there's some things here I want you to notice. This takes us back to chapter 3. Chapter 3. So if you can think back to chapter 3, it's where we had parallel lines cut by a transversal, and we had 4 special angle relationships that we went through that chapter. Okay, and those 4 relationships were things like alternate interior angles. We had alternate exterior angles. We have corresponding angles, like those. And we also had consecutive interior angles that were supplementary, right? The other 3 that I mentioned were congruent. So as I look at number 3, notice on this one, they didn't mark everything like they did on the first 2. So I need to do a little extra work here to mark the things that go together before I try to name this information. So let's take a look at what we have. First things first, let's look at what they did mark for us. Single mark here, single mark here. So I know that JM is congruent to KL. All right, those 2 sides are congruent to each other. I know that the left side is congruent to the right side. I can tell by the double marks here and there. So what about the third side? KM. Well, here's a real popular one for this chapter, right? It's the same thing that happened over here on this one. If you look at KM, KM belongs to both triangles. They share a side. Well, naturally, KM is congruent to itself, right? So I know that KM from this triangle would have to be congruent to KM from this triangle because it's the same line, so it's congruent to itself. If you remember what property that's called, this goes all the way back to chapter 2. That is the reflexive property. Reflexive property says that something is congruent to itself. And we'll use that quite a bit this chapter, so that's one we want to be familiar with for sure. So I got the 3 sides. Let's look at the 3 angles. So here's where the parallel lines comes into play. Here's where I want you to remember is alternate. So this one and this one. Alternate interior angles. So if I look at the top line and at the bottom line. So it looks like this. Top line, bottom line. Here's the diagonal. Looks like this. So if this line is parallel to this line, in other words, this line is parallel to this line, that makes this angle, which is this one, congruent to this angle, which is this one, by alternate interior angles theorem, right? So it takes us all the way back to chapter 3, alternate interior angles theorem. So there's something I can mark. What else could we mark? Let's look at these guys, all right, left and right. So here's the left side, here's the right side. Again, here's my diagonal. Looks like this. So if this line is parallel to this line, right, that's what they marked, those triangles. Well, then what's true? That would make this angle, which is him, congruent to this angle, which is him, for the same reason. Those guys are alternate interior angles theorem, right? So now as I look at those, I'm thinking, okay, great, I got almost everything figured out. I just don't know what the third angles are. So here's where that third angles theorem comes into play from up above, right? If you know that 2 of the angles from one triangle are congruent to 2 of the angles from another triangle, then automatically the third angles must be congruent to each other. So I'm going to use third angles theorem to mark that angle J is congruent to angle L. So by those markings, what I'm going to do on this one, and I'm going to show you because, you know, with these 2 triangles, it was easy to tell what goes with what. All right, the markings were there. The 2 triangles are drawn going the same direction, which makes it real easy to tell the corresponding parts. These ones are a little trickier because they're not running the same direction, right? It's like one's been flipped, and it's a little harder to see what goes with what. So I'm just going to actually start by writing my congruence statement, by looking at my markings. So I can see that angle LKM, so I'm going to call that, so in this triangle, I got 3 letters, right? LKM. So I want to put those 3 letters in the same order as those 3 letters. So I can see that angle K from the top triangle goes with angle M from the bottom triangle. So I know that K corresponds to angle M. by the double marks, right there and right there, I can see that M from the upper triangle corresponds to K from the bottom triangle. So again, this one the first one is representing my upper right triangle. The second one is representing my bottom left triangle. So again, from the upper right, I can see that M goes with K on the other guy. And then the third angles on the upper one, L, goes with J. So those are my congruent triangles. Now let's match up their corresponding parts. Guys, here's the beauty of writing this first, is now, just like I did in this one, I can actually go off of my congruence statement rather than the drawing, which I think will be more helpful, because a lot of times people will mess up the order on this because they're going off of the triangles, but again, visually that's tough when they're not going the same direction like these ones are. So I want to start with the first angles that go together. I can see that angle K goes with angle M. Here's one of the issues, though, unfortunately, when they draw the triangles that are touching, right, when they're connected. So now when I just say angle K, we wouldn't know which angle I was talking about, right? If these were drawn separate, if it was drawn more like this, here's kind of a smaller version of it. So if they were drawn not touching, like this, right, then I could just use single letters, but because these are actually connected, right, they share this line, I can't just say angle K. So I am going to look at angle K matching up with angle M. That's what I'm going to do first. I'm just not going to call this angle K. I need to call it with 3 letters. So I'm going to call the first one angle LKM. Is congruent to this one, which I'm going to call KMJ. And now let me look at this middle one. So M on the upper one with K on the bottom one. So I got M on the upper one, that's the double marks, is going to go with those double marks. So I'm going to call this one LMK. So LMK would correspond to JKM. Guys, even the order that I'm writing this is significant, right? If you look at it, right? So if I said LMK, right? If that's the direction that I go, I went with the 3 marks to the 2 to the 1. I did the same thing here. I went from the 3 to the 2 to the 1. So I even kept that order consistent as I'm just identifying angles. So as I look at the third ones, this will be easy. This one I can say angle L is congruent to angle J. So L is congruent to angle J. So I'm allowed to do that for the third ones. The segments, again, I can look at this to do it, or I can look at this to do it. I know that KM goes with MK. So you'll notice, this is the reflexive line, right? That one right there. So you'll even notice the order that I wrote those really does matter. I could say that KM is congruent to KM. That's true. But as far as appropriately naming the congruent parts, right, really in theory we should be considering the order that we write those in. I know sometimes, and even the book will get a little lenient on that, and they'll say it's okay to just say KM is congruent to KM. But we should be really careful. It really should be a strict order to this if we think about it. So I know that ML would go with KJ. And that's why I said I do think it's helpful to look at the congruent statement rather than the diagram. And then I have the last one. I'm going to say KL goes with MJ. All right, so there's our 6 corresponding parts. So that's the whole idea. We're identifying the parts in the diagram. We're writing a congruent statement. We're also identifying all 6 parts right there. So now let's see how we can put some of this to use. So suppose these two triangles are congruent. Let's see if we can figure out x and y. So guys, here's the super big deal with the congruent statement. It is really hard for me to look at these visually and say, oh yeah, that angle goes with that angle. Right? I'm not really sure because they're not running the same direction. One's like tilted. I don't know if it's been flipped. It's hard to tell. So I'm going to refer to this as my safety net here. This is going to tell me what goes with what. Like for example, when I look at this, well, angle D, well, what does that go with on the other triangle? Well, look at your congruent statement. D corresponds to A. So I know that this angle is equal to 65 degrees. So I'm going to say 2y minus 5 is equal to 65, and now I can solve that equation real easy. So it tells me that y is 35. Let's do the same thing for x. Right? So I have this guy over here, EF, what does that go with? Well, let's look at this. EF must go with BC. So here's BC. So I know that 2x plus y equals 90.6. Keep in mind, we now know that y is 35. Right? We figured that out already, so let's substitute that value in. Subtract that 35. So if I did 90.6 minus 35, I'm going to get 55.6. And then divide both sides by 2, and we got our value for x. Let's see, 55.6 divided by 2 is going to give us 27.8. Right. So that's how we can put that congruent statement to use. Recognizing that the order matters really helps on those guys. All right. Let's look at some proofs. Guys, again, if you are copying this down by hand on your own, you do need to write down the full examples that I'm talking through right now. Okay, so you need to write down this full example, and you need to write down this full example. So make sure both of those go into your notes. And there's one idea up above I want to talk about, but I'm going to wait till the end of this proof to talk about it, so you can see how it works. Guys, first things first, they're giving us some information, right? Every proof is going to start with some given information. The one thing I want to do is mark my triangle with my given information. Marking diagrams in this chapter is going to be more important than any other chapter because, and you'll see why as we progress through this, but I need to know these markings. So AB and CB. They told me that AD and CD. I'm going to give those guys the double marks. And angle BAD, so this one right here, is congruent to BCD. That one right there. So that's all we know so far. So if we were doing a proof on this, I know this too, but we'll get to that in just a second. So if we were doing a proof on this, after I write all this given information, right, the goal is always, okay, what more can I say? What can I do next in my proof? Right? Well, there's a couple things. So let's look at what more we could do. Let's just start with the given information. That's usually where I would start. What more could I do with this given information? Well, according to that statement, they just told me that BD is bisecting angle ABC. So if this angle is being bisected, remember what we've learned about that. Bisected means it is being cut into two congruent angles. Right? So now in my proof, I could say that angle CBD is congruent to angle ABD by the definition of angle bisector. Definition of angle bisector, right? That was on our chapter, I'm trying to think back. It was either chapter 2 or 3 tests, but I know it was on one of those 2 tests. So that made it into the proof right here. So we've done that, we've done that, we've done that. So let's look at the diagram. I've really exhausted the given. Right? Now I'm looking at the diagram. And I'm looking at that diagram saying, what more could I say? Well, obviously, here's a big one. BD is common to both triangles. So, of course, BD from the top triangle is congruent to BD from the bottom triangle because it's the same line. Right? That is our reflexive property. So I'm almost there. I've said all 3 sides are congruent. I've said two of the angles are congruent. So here's that theorem we talked about on the first page. I can now say that the third angles, which are, and I'm kind of running out of room here, but I'll squeeze it in. The third angles, which is that guy and that guy, are congruent by our third angles theorem. So now we've done it, right? I was able to prove that this triangle is congruent to this triangle because all 6 corresponding parts are congruent. Here's the reason our book throws in for that. They're now going to say that this triangle is congruent to this triangle because, here's the abbreviation, corresponding parts of congruent triangles are congruent. Corresponding parts of congruent triangles are congruent, CPCTC. So that's what it says up here, right? So 2 triangles are congruent if and only if corresponding parts of congruent triangles are congruent, right? So that's the reason they're going to give once you've proven that all 6 corresponding parts are congruent. So that's the goal on these proofs. So let's see if we can try something on our own. Same thing. Let's see what we can come up with here. So I'm going to move through this pretty quick, but again, if you're taking your own notes, please make sure that you copy this information down. Just to save a little time here, guys, I'm going to throw in, I'm going to do something I'm going to ask you not to do when you do your homework, but I'm going to just say, here's all my given information. I should be writing all that here as my first statement, okay? Just to save a little time on the notes, I'm just going to say, here's my given information, okay? In the homework, I do want you to write this stuff out because that's what you'd have to do on a test, okay? And so there's my given information. It's given, all right? So I'm going to save myself a little time, but one thing I am going to do is mark my diagram with this. So A is congruent to C. That was given. D and B. So those guys are good to go. AD and CB. AD, CB. AE, CE. AE goes with CE. And the other piece of information they're telling me is this guy right here. So let's look. We got a lot we can say here. So I can pull in more information off of this. I can also pull more information off of this, right? So if AC bisects BD, so here's AC, right? It says that it is bisecting BD. In other words, BD is being bisected. BD is being cut into 2 congruent segments, right? So I need to be able to now say that DE is congruent to BE by what reason? What reason did we just use? We just used the definition of a segment bisector. So when you're bisecting segments, we say it's the definition of segment bisector. If you're using angles like we did up above, it's angle bisector. So definition of segment bisector. All right, what else can we say? Well, there's only one more thing I need to know. This angle and this angle. So what would allow me to say that this angle is congruent to this one? Well, you actually have 2 different possible reasons right now, you could say. One would be what we just did up above, this one, third angles theorem. We're given 2 of the angles, right, here and here. So I could say that angle AED is congruent to angle CEB. Notice the order that I kept those in, according to that congruent statement. But I'm naming those 2 angles by, I could either put third angles theorem here, which would be totally acceptable. So third angles theorem. But what other one could I have said? Something we've been using since chapter 1. Vertical angles theorem, right? These are vertical angles, so I could have also used vertical angles theorem. So if you went with that, that would be fine too. So either way, I now have all 6 corresponding parts. So they want me to say that the triangles are congruent. CPCTC, corresponding parts of congruent triangles are congruent. And I'm going to bypass this final one because there's nothing new in here, right? We've already covered this information, and so I've shown you as much as you can see on this page, so we'll call that good for this section.